Hey, what's up everyone? Danny here, and welcome to the new office, workspace, YouTube studio, whatever you want to call it. This is the room in our new place that I'm going to be doing most of my computer stuff as well as most of the YouTube content creation in. We moved all this stuff over here ahead of time to lighten the load when we do our final move of all the essential things. But because of that, I don't have access to all my stuff that I usually use to make my content, or all my things that I usually do videos on and my builds and all that. And I've told you guys leading up to this that I will find someone to make an interesting video for you. So yeah, let's go and try to convince someone to do that.
Okay, Danny. Okay, I'm here. He is like much larger in real life than he looks. Oh my. Okay. Just don't poke me again. Hi everybody, welcome to Nerd on a Budget. So Danny wanted me to come here and make a video for you guys about power supplies, and at first I said no. Now he came to my house. I don't know how he found out where I lived and how he's poking me, forcing me to do this. So I guess we'll just do it. He's a nice guy, mostly. Anyway, this is a very difficult topic to discuss because this ain't fucking electrical engineering 101. This is a YouTube video. So my goal is to give you a pretty good idea as to what makes a good power supply without being too overly complicated and boring you to shit. But there are a lot of misconceptions among consumers about what makes a good one, what makes a bad one, how you tell the difference. So I figured, I guess this really isn't such a bad idea to sit down and do it. Before we begin, let's understand together what exactly a power supply unit is. So what it does is it takes your power from the wall, which typically comes in at 120 volts through the wall in North America. It's higher if you're in Europe, and it takes that alternating current and puts it through a bunch of complicated machinery that can kill you if you touch it, and outputs it in various different voltages in direct current, DC. Power supplies are divided into two larger parts. One, the primary side, is what takes in the juice, and the secondary side is what breaks it down and spreads it out. And for the most part, the quality of power that gets outputted to your system is really dependent upon the secondary side to sort of smooth it out and make sure it doesn't blow nothing up. Now, it would be great if all of us had component level knowledge of power supplies so we could open them up, take the tin off and just go, oh yeah, look at that. Fucking, that's a chemicon capacitor. I know what that is, and that's especially good compared to those shitty caps on ones. It would be nice if we all could do that, but that's really impractical. These things are screwed shut and they void the warranty if you take the lid off. So what people do is they look at review sites who test these things and actually stress these components to ensure that they deliver the power that they are supposed to deliver, in addition to a few other things. And I think that's what we should talk about today. So really, in truth, what this video is really about is not about how power supplies actually work, even though I just gave you a brief overview, but more so about how to interpret someone else's work when reading a professional review. So the first thing a power supply needs to include is load testing, and this load testing usually takes place in both a cold environment, or just ambient room temperature, and a hot environment where they purposely push hot air into the power supply, trying to get it up to its maximum temperature to see if it will operate in the most extreme of circumstances. Load testing usually involves anywhere from 5 to upwards of 7 different stages of load. So you'll go all the way from idle up to its sustained wattage maximum, and maybe even a little bit over in the case of some reviewers. They sometimes like to take 650, 750 watt units and push them up to 800, 850 watts to see just how high these things can go under stress. At a bare minimum, they will test at least 20, 50, and 100% of maximum sustained wattage load, because these are the 3 levels that testing must be completed by the manufacturer in order to qualify for 80+ certification. Now, some of the higher certifications actually include 10% testing as well. So for those reviews of those units, you'll usually see 10% included as a requirement as well. And now that we're on the subject of efficiency, the 80+ certification program has to do with the conversion efficiency from AC to DC. So if you're getting 80% at 20, 50, and 100% load, you're going to get 80+ certified, just the plain old white one. The bronze and silver and gold and platinum and now titanium certifications all apply to higher levels of efficiency as you go up at those tests. And the reviewers will actually use these load tests to validate those certifications. Now, the reason we do it in both hot and cold is because power supplies supplies, yes, under normal circumstances, will usually be sucking in air that's room temperature, but on occasion, people will have up-facing power supplies if they're base mounted, and will be taking in warm air from the system and exhausting it out the back. Now, usually the ambient air in your case, unless it's terribly designed with horrible airflow, is gonna still come in no hotter than about 35 degrees. But in the event that a person has a configured system that is sucking in a lot of hot air, you wanna make sure that you can hotbox this power supply and still have it work as intended. Now, another thing that makes a quality power supply unit is making sure that the output voltages are all within spec. And you do this by measuring them during the load tests. Now, these voltages are allowed to deviate from their target just a wee little bit, but reviewers will usually put a hard limit on how far they can go before they give the unit a fail. One of the biggest indicators of a shit, poor quality unit is that when you start to take it to higher loads at higher temperatures, voltages will go way out of spec, which is incredibly dangerous. And if the unit doesn't shut down like it's supposed to thanks to something called overvoltage protection, your components could be at risk. Now, when you're measuring for voltage regulation, there's minor variations in the output voltage that don't show up on a multimeter or on your motherboard that can be important depending on the scenario, and this phenomenon is known as ripple, and it's usually associated with turning AC power into DC via some mechanism. Ripple is measured with something called an oscilloscope, and almost every good review will include it. If it does not, it's probably bullshit and you should ignore it altogether. And the last thing a good reviewer will do, although not all of them do it, is a full disassembly of the unit. Now, this is obviously the least relevant part of a review for you, the reader, because you're not going to know the difference between one doodad and another, but they usually will. So if you read their write-up and they see anything that's glaringly obviously bad, they'll usually let you know. But modern power supplies made by reputable manufacturers, names that you trust, are usually not made with components that are total shit. Yes, they'll be minimally good, but they'll still usually meet spec, and any problems that might arise from the quality of the component itself will usually be revealed in testing, which is what's most important. One more thing I'll mention before moving on is that some reviewers are especially attentive to detail, and they'll actually reduce the input AC voltage into these units while testing them at about 100 volts just to see how the primary side responds to the reduction. This is not particularly pertinent to the average person, as most of us live in houses or apartments where we're getting 115 to 120 out of the wall, but technically it is a range. It can go anywhere from 100 to 125 and still be in spec, so good on them for testing it. The real reason these reviews exist is to keep you from buying shit that will blow up your house. Anything else that exists between the budget but passable units like the CX series or the B series from UGA all the way up to the expensive AX 1500Is from Corsair are all just little nice to have bits of minutia. Really, all you're looking for is something that will work when you plug it in and won't explode your crap. But if you did twist my arm and you asked me for which power supply in particular I would recommend that you buy right here, right now, it's hard to choose any given one, but what I'll say is this. Your power supply is an investment, and being cheap isn't necessarily always the best way to go, and being frugal is not always necessarily being cheap. Think of your power supply as an investment that will yield returns over the long term. Yes, you can technically go out and buy a CX 550M, and it'll be perfectly fine for its entire warranty period, which I think is 5 years now, which is pretty goddamn good for a low-end unit. But if you're willing to spend 40 to 50% more on top of that unit's cost to get something that lasts you 10 years, which is twice as long, it's obviously a much more sound investment. Anyhow, I hope that's enough. I've blathered on for like what looks to be about 7-8 minutes now, so hopefully this guy can get the fuck out of my house and I can go back to living my life.
Perfect. Alright, that's gonna be it for this video, guys. So I just want to give a huge thanks again to Oafah for his willingness to help me out. And be sure to go check out his channel. We've worked together in the past before, so you've seen his face. But I can't stress enough how much I respect this guy and his knowledge when it comes to computers and just his attitude with, you know, no BS. So be sure to check him out, and I will see you guys hopefully next week when the room should be done. But if it's not, we'll figure something out. But yeah, so see you in the comment section and in the video next week. Bye.